Hi everyone, this video is for section 3.4, rational functions. In this video we're going to analyze number 33. In this problem we're supplied a graphic of a rational function, and what we're going to do, or our main objective, is to actually create the function that would generate this image. So as you can see underneath the image, I have a checklist of items that we're going to go through in order to help us successfully piece together what this function is going to look like. So to begin, I'm going to put in my function notation on one side of the equation, and then I'm just going to put in my division bar or my fraction bar here. So the first thing that we're going to go ahead and do is we're going to take a look at the X-Intercepts. Those would be found in the numerator portion of our rational function. And hopefully you can see these red dots kind of popping up against the pink line. But we do have an x-intercept at the origin, and we also have an x-intercept at the point 3, 0. So recall that when you are actually writing these into your rational function, you need the expression that would give you a result of x is equal to 0 and would also give you a result of x is equal to 3. So if you're not sure how that's supposed to go about, we can basically work our way backwards from what I have written up here at the top of the screen. We can subtract 3 from both sides, and that would give us an expression of x minus 3. And technically you could do the same thing if you subtract 0 from both sides. You would have x minus 0 is equal to 0, but that seems kind of redundant, and it kind of gives you a lot of extra fluff to have to look at. So we can boil that down to simply x is equal to 0. So we're going to go ahead and put those two expressions in our numerator. So we are done with the first item. So now we're going to go ahead and start looking at the vertical asymptotes. Recall that vertical asymptotes essentially act as kind of an invisible barrier or an invisible fence that your function is not allowed to cross. It can get really, really close to it, but it cannot actually break through these vertical asymptotes. So I do have a vertical asymptote at x is equal to 4, and I also have a vertical asymptote at x is equal to negative 3. Remember that these vertical asymptotes also tell you that this is where your function cannot exist. And with regards to a rational function, that would be when the denominator would be equal to 0. So again, we can do the same thing when we are putting these into our rational function. So we would do the opposite, essentially. We would say that this would be x plus 3, and then we would say that this one over here would be x minus 4. And just like that, we are done with the second item on our list. So the next thing that I want us to take a look at is going to be the horizontal asymptote. And let's spend a little bit of time on this. Horizontal asymptotes, what you want to note is if you refer to your book on page 194, there is a brief summary up at the top of the page that indicates what kind of horizontal asymptotes you could have. One situation would be if the ratio of your degrees, if the degree in the denominator is greater than the degree of the numerator, then our horizontal asymptote is laying right on top of the x-axis. It's acting as the y equals 0 line. If the second situation that you have is if you have a degree in the denominator that is less than the degree of the numerator, then there is no horizontal asymptote. And then finally, the third option would be if the degree of the denominator equals the degree of the numerator, then you're going to basically have a ratio of the leading coefficients found in the numerator and the denominator. So we kind of have to look at it from the reverse. We don't want to look at our answer right now and do a ratio and look at the degrees of the numerator and the denominator. We already know that we have a horizontal asymptote here at y is equal to negative 2. So that tells me, since I am working with a horizontal asymptote that is not on the y equals 0 line, that tells me that the degree of the numerator must be equal to the degree of the denominator. So at this point, we can check to make sure that we are all on the same path here. If not, then we would have to adjust our function. So right now, if we're taking a look at the numerator, here for our first factor, we have a degree of 1, and our second factor also has a degree of 1 to give me a total degree of 2 for my numerator. And then if we go ahead and move down to the denominator, we do have a degree of 1 here. We also have a degree of 1 here, so that tells me that my denominator will also have a degree of 2. So we are on the right track. We don't have to make any sort of adjustments to our work. So since we do have a degree, the same degree in the numerator and the denominator, we can basically go ahead and say, okay, well, by the rule, it says that if those degrees are equal, our horizontal asymptote should be a ratio of the leading coefficients. So in this case, if we want a ratio that's going to result in a -2, that means that we must actually have a -2 on top. And technically, we do have a number 1 on the bottom, because the ratio of -2 over 1 would simplify to a -2. Now, you don't need to include that 1. It's redundant, and it's not necessary to include. But basically, now that we have that all situated, we are all done. We've taken into account the X-Intercepts, we've taken into account the vertical asymptotes, and we have taken into account the horizontal asymptotes here. So at this point, we are all set. So here is your final solution. If you do have any other questions, please feel free to come see me. Thanks.